the average rate of change of a function. So I want you guys to think about when we did that 1x squared, okay? Again, when we just went from 0 to 2. And this went to 4 here. Okay. So, but I want you to think about this a different way, just a slightly different way. So if I go from f of x plus h, so let's say x is 0, and x plus h is 2. And then that would mean that x plus h minus x would just be h, right? So what we want to do is, if I want to find the rate of change, that average rate of change from 0 to 2, which was this line right here, the slope of this line, then this is the same thing. This is just now I have a rate of change of 2. Or I could go 1 to 3. Let's say I wanted to go from 1 to 3. Now let's say x equals 1, x plus h is 3, h is 2. So I'm only changing by 2. Oops. But now I want, well, this thing's going crazy on me sometimes. Okay, well, that was before. That's the other one that we did like that. There, I got it fixed now. So essentially all we're doing is finding f of 3 minus f of 1 over h, which is 2. But this is f of x plus h, and this is f of x. So in this case, 3 squared is 9, 1 squared is 1 divided by 2, which is 8 over 2, which is 4. So now the average rate of change from 1 to 3 is actually 4 units. So this one changes. It depends if I go 0 to 2 or I go 1 up to 3. See, that one's a lot sharper. You can see my pencil going up and down. So this is no different than doing something like that. So let's look at this next example. This is x squared plus 1, so it's just moved up a little bit. So let's say somewhere I just pick an x. I don't care where. It looks like negative 1/2 or something. I just picked an x. Okay? So I want to go over h units. Okay? So this point right here is x plus h. So this is x plus h. So this direction is the function. So this right here is the function at x, and this right here is the function at x plus h. So to find that rate of change on this secant right here, I'm just f of x plus h minus f of x divided by x plus h minus x is just h again. So I'm just trying to find the slope of this line of anywhere, any place that I feel like putting it. And then all I have to do is plug in an x where I want it to be, and I can find it immediately. So let's substitute x plus h for x. So f of x plus h, which means every single time you see x, you put x plus h in instead. It does not mean add an h to the end of this. This means that you have to take x plus h, square it, and add 1. And remember, when we square things, remember first plus last, oops, squared is the first term squared plus 2 first last plus last squared, okay? If you forget this, I want you to think of something like 12 squared. Most of you know that this is 144, okay? Well, it's also 10 plus 2 squared. And it's not equal to 104, right? It's 144 because you need 2 times the first times the last. Watch this. 10 squared plus 2 times 10 times 2 plus the last term squared, 100 plus 40 plus 4 is 144. Works for any two-digit number, by the way. So, works very nicely. If you want to square 24, the square of 24 is, well, the square of 20 is 400 plus 2 times 20 times 4, which is, let's see, 2 times 4 is 8. 8 times 20 is 8. What did I say? 8 times 20 is 160. So we have 400 plus 160. So we're at 560 now. So keep that in your head. And then 4 squared, which is 16. So it's 576. So you can actually figure out large squares by using this formula. So this means x plus h is x squared plus 2xh plus h squared plus 1. So this is going to give me a formula to find the average rate of change for any x and h. So we're going to start just by finding what f of x plus h is. And this is what it is. This is f of x plus h. So now I want f of x plus h minus f of x. So let's write this down. X squared plus 2xh plus h squared plus 1, that just comes from right here, minus the quantity x squared plus 1. So we have to be really careful. We have to put that in parentheses, because if we don't distribute the negative. So that actually means minus x squared minus 1. Well, these go cancel away, and we end up with 2xh plus h squared. That's nice. So now that's that part. So now we want this whole thing. So remember, this thing at the top was equal to 2xh plus h squared. Now at the bottom we have h. Let's distribute that h on the bottom. 2xh over h plus h squared over h. So it looks like I have 2x plus h. Well, that's nice, because now I can pick anything for x and h. I can say, well, what about from 2 up to 10, up to, I don't know, let's pick a bigger one, up to, say, way up here at 5, what would the average be? So between 2 and 5, so I'd have x equals 2. What's the difference between 2 and 5? It's 3. So I would know that the average rate of change is 2 times 2 plus 3, which is 7. And I would know that the average rate of change from 2 to 5 of x squared plus 1 is 7. That's the average rate of change. Pretty neat. And that's all I really need. It's nice to have that situation happen. So this is something that we use a lot in calculus, these average rates of change and things like that. So it's really, really nice to have that. Okay. So let's try this one more time. We have a function. Now this one's interesting. This is a constant function. So we actually know what the rate of change is. So let's keep that in mind. We know that the average rate of change is going to be 12. We know this is a constant rate of change. So how does that compare with the average rate of change? Let's see what happens. Let's find f of x plus h. So this means everywhere that I see x, I'm going to put in x plus h in parentheses. So 12 x plus h plus 5. So this is going to be 12x plus 12h's plus 5. Okay, so the next thing I'm going to do is I'm going to find f of x plus h minus f of x. So let's remind ourselves what f of x plus h was. 12x, 12h plus 5 minus the quantity 12x plus 5. So you're noticing a pattern here, I hope, that the original function has a tendency, when you do this, to get subtracted away. Negative minus 12x minus 5. These cancel, I just ended up with just 12h. So now let's put that over h. So we know this is 12, this thing, all of this is equal to 12h over h. Cancel my h's, I get 12. Oh, wait a minute. So that is my average rate of change is equal to my slope. And why is that true? Because my f of x was a linear function. Since it's a constant rate of change, my average rate of change is my slope. It's all the same. And yes, I kept you for 48 minutes. And that's it. We'll do some more in class, and I will see you then.